Assalamu alaikum. This is MATLAB course, lecture number 1, part 2. It's supposed that we solve some exercises, but before that, let me talk about two things. The first one, uh, how we can use the logical operators or operations on matrices. Let me write M equal, say that 1 to 3. 1 to 3, that means 1 and 2 and 3. They are the elements in the first row. Then go to next row from 6, say that to 9, 6, 7, 8, 6 to 8. So you have a matrix 1, 2, 3, 6, 7, 8. Now I want to find, or I want to say that M equal to 7. This is a logical operation. M equal 7. That means it will take element by element of M and check the element. If the element is equal to 7, it will return a true or 1. If the element not equal to 7, it will return 0, which is false. So as you see, we got a matrix 2 by 3, same M size. Now how that come? Now 1 first element, is it equal to 7? No, the result will be 0, false. 2 equal to 7? No, and so on and so on. 7 equal to 7? Yes, so the result will be 1. Let's say that m greater than 4. Enter. M greater than 4. Enter. We got this matrix, same size of M. Now again, it will go to M. It will take element by element. The first element, is it greater than 4? No, the result will be 0. Take the 2, is it greater than 4? No, 0. 3 greater than 4? No, the result will be 0 or false. 6, yes. 7, yes. 8, yes. So we got this one. Say that I want to generate a vector V, and this V elements, they are all elements in M matrix where the element greater than 7. I will write V equal M of M greater than 7. Greater than 4, sorry, greater than 4. Now M greater than 4, it will return a matrix, this matrix 0, 0, 1, 1, 1. Now M of 0 here, that means M of false, don't take the element. M of another 0, false, don't take the element. M of 0, false, don't take the element. M of 1, that means take this element, which is 6. Then M of 1, that means of true, take the element, which is 7. This one true, take the element, which is 8. We got this one. So we get a vector. This vector, the first element is 6, second element is 7, and then 8, because they are greater than the 4. Now, as you see, we can use the Boolean or logical operations to get some useful information from the matrix. The second thing here is how to write a script file, how to write a full program, complete program. Surely it's not a good idea to write everything like this, one line by one line. It's very difficult, and it's not supposed to do that. To do that, let me clear the workspace also. Clear, and I'll see to clear the command window. We have to go to a new file. From new file, we select script. As you see, once we selected the script or open a script, another area appeared at the middle here. So as you see, this is the editor where the file untitled name is untitled. The name of this file untitled. Okay. Under the untitled file, we have the command window. Still, we have it here. workspace still here, and current folder here, and details here. My advice to you all, at the beginning we have to use CLC. At the beginning of any file or program in MATLAB, use CLC to clear the command window, to show the new informations or outputs from your program. And then clear the workspace, because I don't want the previous values affect my new variables. So it's better to clear everything in the workspace. The workspace represents the memory of the file. Then close all. These are for figures. Close all figures to start a new figure. These three, CLC and clear and close all, it's better to start any program always by this. Now let us read the class notes or the exercises. We have to, So let us start solving some exercises for this lecture. Exercise number 1. It says that in a script file, create a vector of all numbers between 6 to 23 using colon operator. So we can use a comment, by the way, percentage. We can say that as example, exercise number one, how to create a vector. Okay. Percentage, it used to make a comment. Comment means it's not executable line. That means this line will be not or executed in the run. Create a vector of all numbers between 6 to 23. I can say that a equal to start from if I started from 6, add 2, then it will become 8. I will get the even numbers. So let me start from 7. More than 6, because I know that the first odd number is 7. Then increment it by 2 until reach what? Until reach 23. 23 like this. Like this. Okay. Now how we can run the program to see the result. Save the file as .m. Write a name, then .m. As you see, we have a variable a here, and these are the values. We can see them clearly here in the workspace. But if you want to check them, say a, enter. Why I didn't get the result before here? Because I used in the program semicolon. That means I don't want to see the values of a in the workspace. But if you want to see, write a, enter. Now as you see, a equals 7, 9, 11 until reach 23. Second part, it says that create b vector of the square of all numbers between 6 and 3 using mod function. Mod function, it's a modulus function. So when we write modulus of 5 to 2, the remainder will be 1. That means inside the 5 we have 2 2's and the remaining is 1. Actually, all odd numbers modulus to 2 will be 1, and all even numbers modulus to 2 will be 0, or the result will be 0. So how we can do that? Again, we can copy the comment, Ctrl+C, Ctrl+V here, and write I want to generate a b vector. We can say that b vector equal. Now we need all of the square of all odd numbers between 6 and 3 using the modulus function. How we can do that? How we can generate? I know that I have these numbers between 6 and 3 saved in A, but I can't use modulus in this case, so I have to create them again using the modulus. So I will write as example, say that all equal, I will start from 6. I will start from 6 to 23. This line, it will generate a vector, row vector, start from 6 to 23 incremented by 1. So it will be 6, then 7, 8, 9, 10 until reach 23. So these are all numbers. Now I will use the modulus and the square. So I can write b equal, say that all when the modulus modulus of of all to 2 equal to 2, or sorry, to 1 if you want to take odd numbers, to 1. Again, all of modulus of all to 2 equal to 1. Now when we write modulus of all to 2 equal to 1, it will return, it will take all of elements of all, element by element, and check the modulus of that element to 2. Is it equal to 1? If yes, it will return true or 1. If false, it will return 0. So let me do it. I will show you here in the command window. I will write all equal to 6 to say that 6 to 20, 23. I don't want to see the result in the command window. Then I will write modulus. I will show you modulus of all to 2. Is it equal to 1 for odd numbers, like this. See the result. Remember that start from 6 to 23, the vector all. Start by 6. 6, is it even or odd? It's even. Modulus to 1 to 2 equal to 1? No. False. Second one, true. False, true, false, true, false, and so on. So when you put all of these as a logical values inside here, instead of this one, and take all to these values, when the value represent false, it will not take the element. When the value represent true, it will take the corresponding element. So CLC, okay. So B equal all of modulus all to 2 equal to 1. If you want to execute them, right click, select them, then evaluate selection, and the selection here evaluated. See, this is the B, to be sure that we got good results. As you see, we have 7, 9, 11, 13, 15, 17, 19, 21, 23. But the program asks us to do what? The exercise, create b-vector of square of odd. How to make square? See, all of these we can write like this and like this. Then we can write power to 2 like this. But remember, it's algebraic multiplication here. We have to use dot to use element by element. Now let me run this code again and see the result. It was 7 before, 7 to the power 2, 49, then 9 to the power 2, then 11 to the power 2, then 13 to the power 2, and so on. The third part, find length, max, min, sum, product of a vector A. Save all of them in a new vector B. Actually, again, start from comment. Say that I want to generate vector P. For the vector P equal, start the vector, the first value, it is the length of A. So we use the built-in function called length and just write length of A. That's it. Comma or without comma, it's up to you. Max of A. Same thing for the third one is minimum, min of A. Okay, and then sum of A. A is a vector, write sum, no problem. If a matrix, write sum. And product, last thing, product of A. That's it, semicolon. Let me evaluate this line and show you the result. Let me evaluate without semicolon. Right click, evaluate selection, and now it will calculate the result. Oh, there's a mistake here, I'm sorry. This one like this one like this. Apport. I use Ctrl+C to abort the running process. So CLC again, let me evaluate it again, select all of these again, sorry, evaluate selection. As you see, we got all of these. This is the represent the length and max and min and product. This is a type of number. CLC again, you can see P, it's 9, 23, 7, and so on. Next one, create a linearly spaced vector V with 10 values in the inclusive range from 0 to 50. So again, we will start by comment percentage, say that exercise number 1, we need to find V. Write V equal, use the built-in function linspace. The initial or the start point will be 0. The final number should be 10. 50, not 10. 50, and between 0 and 50 we have 10 numbers, 0 and 50 included, like this. That's it. If you want to see the result, you can evaluate to check the result like this. CLC. We finished the first one. The second one, we can open a new script. As you see, again, start by CLC, clear and close all. The second question, it says that in script file, define x by these values. So I will Ctrl+C, go to here, Ctrl+V, then write semicolon. Let me evaluate this one. Evaluate, we got the x vector. Okay. Add 2 to each element in x and keep result in the same vector x. We can write x equal the old x plus 2. That's it. Let us check the result and show you the output. See, the old x is 2. 2 plus 2 is 4. The old x here, it's 5. 5 plus 2, 7, and so on. CLC. Next one, add 3 to just the odd elements of x and save the vector in y. So we can say that y equal, okay, the new x. Use the new x. By the way, when you write x equal x plus 2, the new x will delete the old x. Okay, now we need just the odd elements of a new x. Add 3 to them. So it is 3 plus all odd numbers. How you can find odd numbers? We need the x of these x say that when the modulus of x to the 2, when it is equal to 1, take the element and then add 3 to that element and save it in y. Again, now as you see here, modulus of x equal to 2, it evaluate this one, it will return this vector. The elements are false, true, true, false, true, 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 false, false. When you say x of true, that means take this element. When it is x of false, don't take this element. So x of 0, don't take it. X of 1, take the second element, which is 5. 5 plus 3 will be 8, and so on. Now, this is the values, odd numbers, add 3 to them. So let me evaluate all of this one and show you the result. See, 10. This is not odd, this is odd. Plus 3 will be sorry, it should be again, it should be the first element is even. Even, that means false. Don't take this one. Now x of false, don't take it. Second one, it's odd. X of 5, modulus of x of 5 to 2 equal to 1, yes. Take the element 5 plus 3, add 3 to it, it will be 8, not 10. What happened here? I don't know. Let me check again. Let me check again and see what happened. Oh yes, I'm sorry. Remember that before doing that, let me show you the x first. So these are the elements of x, okay? And these are the elements when x modulus x of 2 equal to 2. These are the elements. So the first one is 7. Why? Because 4 it's even. The 7 here, it is odd. So these numbers. Now add 3 to this one, it will become 8. It will become 10. This one plus 3, it will become 6. This will become 16. This one become 10 again. This is 12. So let me evaluate this one correctly, like this. So this is correct because the value of x, it is not 2. It is updated by adding 2 to all elements. Next one. Find the square root of each element in y. Save result in z. Square root. It's very simple. Z equal, we can write sqrt of y. Or we can use, let me write a comment to you. We can say that z equal y to the power of 0.5. Same, okay? But it should be dot power 5 because it is element by element. Okay, next one. Compute the square of each element in z. Save result in same z. So we can write z equal z to the power 2. And it should be element by element, power like this, and then like this. No need to see the result, it's very simple. Define a new vector n which will contain the first 3 elements of x followed by elements of y. That's very easy. Write n equal, okay, we need the first 3 elements of x. So we can write x of 1 to 3, the index 1 to 3, like this. Then followed by all elements of y, like this. We can write like the following, all elements of y, like this, but no need, because when you just write y like this, it will take all elements of y. Let us check this code. Let us evaluate it without semicolon and see. 4, 7, 3, they are the first elements of x after adding 2 to them. Okay, and 10, 6, 16, 10, 12 elements of y. Okay, we finished the second one, the second exercise. Let me go to the third exercise. Open a new script. Again, start by CLC clear, close all, Control C, Control V. In this question, it says that in script file, define A, B, and C. Let us define A equal, as a matrix, we have 13, space 1, space minus 9, space 7, then semicolon to go to next row, 0, space minus 1, space 4, space 6, we can write comma, but no need, it's easier to keep it without comma, just a space, then semicolon to go to next row, 70, space 9, space minus 5, space 7, I finished the matrix. To be sure, I will show you the result by evaluating this code. Right click, evaluate. So we got the result correctly. CLC to clear the workspace. Then B, we can write here B also. B equal to minus 2, 10, minus 3, 2. Actually, this is column vector. So what I will do, I will write like this. Minus 2, instead of writing semicolon to go to 10, I will teach you another thing. Keep it like this, easier. Minus 2, 10, minus 3, 2. But the transpose of it. Okay? Let me evaluate this code without the transpose and show you the result. It will be a row vector. When I will evaluate it with the transpose, we got a column vector. It's same result. It's same like writing here semicolon, 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 but I feel this is easier than the semicolon. Okay. Now the C. The last one is C. C vector equal to 1.1, 1.1 space 3.6 space 5.2 space 6, like this. Evaluate it to be sure. Okay. CLC to clear the command window. Now it says that find D, where D equal A multiplied by B. This is very straightforward. We can write D equal to A multiply by B. Can we make the algebraic multiplication here? Yes. Why? Because A it's a matrix size. It is say that 2. We have 3 rows by 4 columns. So it is 3 by 4. While B it is 4 by 1. So the matrix inner dimensions are agree. They are same. So we can perform the algebraic multiplication, no problem. You want let us evaluate. Okay, this is the result. Next we need E equal B multiplied by C. E equal B multiplied by C. Same thing, the inner matrix dimension agree. We can evaluate it like this. Next we need C equal C plus 4. It just some practice to show you how we can change the values, how we can do multiplication, how we can do operations with matrices. So C equals C plus 4. This is the new values of C. Okay. Now we need II equal A multiplied by A transpose. II equal to A multiplied by A transpose. Can we do that? Yes, because A it is 3 by 4. When we transpose it, it will become 4 by 3. So the inner matrix agree. We can do this multiplication as you see. Next, find size, max, min, sum, and product of A. Save results in the same vector PA. It's very easy. Write PA equal size of matrix A. Okay, but use the bracket here followed by space. By the way, the size of A, when you write size of A, it will return as you see here two values, 3 and 4. Then we need max of A. A it's a matrix. Just to remind you, we can write max of A like this, but when you write max of A, it will take the maximum of each column. It will not give you the maximum of the on the array. So it will give you 4 values. It should be give 1 value. So max of these, it will give you the max. So max of A, as you see. Let me evaluate, show you the result. I think it will be 70 the max. Okay, so evaluate this one. It will be 70. Yes, that's right. And same thing for the min and max and sum. So max, min, sum, same, and product also. So we have to write here min of A, min of A to find the overall minimum in the array. And same for the sum of A, and same for the product, because the product it will give you the product for each column, but product of product will give you the final product, overall product. So product of A, like this. Then close the matrix. So let me now evaluate this one to show you the result. We have this is the size, this is the max, this is the min, this is the sum, this is the product. And as you see, the product is 0 because one of the element is 0 in A. Okay. Calculate absolute of A. Save result in a new matrix A, B, A. We can semicolon say that A abs or A P A P A equal abs built-in function called abs of A. I'll show you the result. The new values, all of these, saved in a new variable called APA, new matrix. See, it was before -9, it is now 9. -5, 5. -1, it is 1, and so on. Calculate the SQRT of C, save result in new vector SRC. We can write the square root of RC, okay, equal to square root of C, SQRT of C. C, it's a matrix or vector. C, here we have a vector, yes, vector. And let us show you the result. Remember C, change by adding the value of 4. So take the square root of C, we will get a new vector like this. Find the round of C, save result in RC. Round of C, round of C equal round of C. Okay, and this is the result here. Okay, calculate the base 2 logarithm of C and name it L to C. Say logarithm base of 2 of C equal log 2 of C. Log 2 of C, and C, it is a capital letter, not small letter. Variables are case sensitive in MATLAB. Okay, CLC, then save B, then C in array 2 by 4 matrix called NM, each one as a row. It's okay. So we have to define a new matrix called NM equal, the first row will be B followed by C. The first row will be B followed by C. So we can write like this. The first row is B semicolon C. Then B, it means all of elements here, and C, it means take all elements and put them here. Let me evaluate and show you the sorry, this is like this. Error using vert cat, dimension of array being content are not consistent. We are talking about B and C. B, because B it's a column vector while C it's row vector. So it should be B transpose to make it row like this. Transpose. Now evaluate it again, we will get a good result. See, this is the B transpose and this is the C. Because B it's a column vector, not row. Just transpose it to get it as a row. Okay. We finished the second one. The third one, same thing. CLC, clear, close all at the beginning. Then the question says that in a script file, create the following matrices. 5 by 2 matrix of random reals. Use rand function. It's very easy. We can write rand of we need 5 by 2. Write the size 5 by 2 like this and save it like this. It's okay. We can say that R real as a variable equal rand of 5 to 2, and I will show you the result here. As you see, we have 5 by 2 matrix. All of elements are randomly selected between 0 and 1, double, as a double or data type double. Second one, 2 by 3 matrix, random integers. It should be from -50 to 50. We can write integer equal rand I. We have to write the size of the matrix. First of all, we have to write -50, which is the minimum value, followed by 50, and then followed by the size of the matrix, which is 2 by 3, 2 by 3, like this. Remove the multiplication just like this, semicolon. Evaluate to show you the result. There is a problem. I think this is the range, also should be between brackets like this and without comma. Yes, see, from -50 to 50, the range, the size of the array to 3 by 2 or 2 by 3, and so on. Okay, next, 2 by 2 matrix of 13s. Say that 13s 30 equal 13 multiplied by ones, because ones create matrix of ones. Now the size, it's 2 by 2, just write 2, it's enough. When the matrix is square matrix, no need to write 2 by 2, just 2. See, all of elements are 13s. CLC, clear. Now the final thing, we have to save the file always. Let me save as, make it save as. Don't forget to write the name .m. Thank you so much for watching this video.